हाँ ठीक है। ये ऊंचा हो गया ना, कुछ हुआ है। ये ऊंचा हुआ तो लेवल सीधा आ गया सामने। Good morning, learners and viewers. We will be talking about Information System for Managers, that is MMPC 008. We will be continuing from Unit 10, that is, we are continuing with it, project identification and selection. The project leader and initial team of system analysts also produce a specific plan for the proposed project, which the team will follow using the remaining SDLC steps. The formal definition of a project is based on the likelihood that the organization's information system department is able to develop a system that will solve the problem or use the opportunity and determine whether the costs of developing the system outweighs the benefits it could provide based on cost benefit analysis. The final presentation with the subsequent project phases is usually made by the project leader and the other team members to the organization's master and or to a specific master committee with experts. Some of them may be from other similar organizations. Now, what is analysis? Analysis is the next phase. During this phase, the analysis has several subphases. The first is requirements determination. In this subphase, system analysts work with users to determine the requirements and expectations of users from the proposed system. The system studies stage analysis, the problems of existing system, manual or automated, in details, identifies objectives to be attained by a solution to these problems, and describe alternate solutions. The system study stage examines the feasibility of each solution alternative for review by master. This stage tries to answer the question, what do the existing system do? What are their strengths, weakness, trouble spot, and problems? Answering these questions require extensive information gathering and research, careful study of current system manual or computerized that might be replaced or enhanced as part of this project, seeing through documents, reports, and work papers produced by existing system. All the information gathered during the system study phase are used to determine information system requirements. Next, the requirements are studied and structured in accordance with their interrelationship and eliminate any redundancies. Third, alternative initials design is generated to match the requirements. Then, these alternatives are compared to determine which alternative best meets the requirements in terms of cost and labor to commit to development process. In this phase, feasibility study of the proposed system is also performed. The three main feasibilities are technical feasibility, which involves questions such as whether the technology needed for the information system exists and whether the firm has enough experience using that technology. Second one is economic feasibility, which involves questions such as whether the firm can afford to build the information system, whether it benefits should substantially exceeds its cost, and whether the project has higher priority than that other projects that might use the same resources. And the third one is organizational feasibility, which involves questions such as whether the information system has enough support to be implemented successfully, whether it brings as excessive amount of change, and whether the organization is changing too rapidly to absorb it. If the information system appears to be feasible from all aspects, then this SDLC phase produces a functional specification and a project plan. In case the proposed system is not feasible to develop, it is rejected at this very step. The functional specification is the description of the alternative solution recommended by the analysis team. Once the recommendation is accepted by the organization's master, the project team can begin to make plans to acquire or to hire IT resources in terms of hardware, system software, and human resources to build or operate the system proposed. The overall requirement is finally documented as System Requirement Specification for further consulting both by users and developers during other phases of SDLC. Logical design. Logical design slays the component of the system and their relationship to each other as they would appear to users. It specifies what the system solution would do as opposed to how it is actually implemented physically. It describes inputs and outputs, processing functions to be performed, business procedures, data models, and controls. Control specifies standards of acceptance, performance, and methods for measuring actual performance in relation to these standards. Logical design is not tied to any specific hardware or system software platform. The system can be implemented on any hardware and system software. Various standard charts and diagrams are prepared by the system analysts to illustrate data flow and processing steps for further use. Then comes physical design. Physical design is the process of translating the abstract logical model into the specific technical design for the new system. It produces the actual specifications for hardware, software, physical databases, input output media, manual procedures, and specific controls. Physical design provides the specifications that transform the abstract logical design plan into a functional system of people and machine. Conversion from logical design to physical designs takes place in this phase of SDLC. During the physical design, the analyst team decides the programming language in which the computer instructions will be written in, which database system and file structure will be used for the data, the platform that will be used, and the network environment under which the system will run. These decisions finalize the hardware and software plans initiated at the end of the analysis phase. The final product of the design phase is the physical system specifications in a form ready to be turned over to programmers and other system builders for construction. The physical system specifications are turned over to programmers as the first part of the implementation phase. Then implementation phase, it is a process of putting a system into operation in an organization. During implementation, system specifications output of the system design phase is turned into working system that is tested and put into use. Implementation includes coding, programming using computer language or languages, testing of the developed software system, and installation of the system. The implementation phase being highly technical, with most of the activities done by the IT professionals. The three steps are coding, testing, and installation have been put under installation phase for business master point of view. The initial installation phase begins with implementation, planning for developing the software by computer programmers using computer language, the process of creating plans for training, conversion from old system to newly developed system, and testing of the system by the technical team and users. During coding, programmers write programs that make up the system. Some system development projects assign programming tasks to specialists who work consist exclusively of coding programs. Other projects prefer programmers, analysts who both design and code software programs. Since large systems entail many programs with thousands, even hundreds of thousands of lines of code, programming teams are frequently used. During the system testing, programmers and analysts test the individual programs and the entire system in order to find and correct errors, if any. This is a very crucial and important phase of SDLC because this is the phase which gets the system developed as per user's requirement, well defined earlier in the analysis phase in terms of SRS. Testing information system can be broken down into three types of activities. First one is unit testing or program testing. It consists of testing each program separately in the system. Testing should be viewed as a means of locating errors in programs, focusing on findings all the way to make the program fail. Second one is system testing. It consists of testing the functioning of the information system as a whole. It tries to determine if discrete modules will function together as planned and whether discrepancies exist between the ways the system actually works and the way it was conceived. Third one is acceptance testing. It provides the final certification that the system is ready to be used in a production setting. Systems tests are evaluated by users and reviewed by masters. When all the parties are satisfied that the new system meet their standard, the system is formally accepted for installation. Unlike the other steps in the life cycle, these steps continue throughout the system's useful life. The end of the system's life cycle is its absorption into another system or its termination. Operation and maintenance. Now, because the system will be in use, the operation and the maintenance phase starts after the users have accepted the new system. This phase can be divided into two activities: ongoing operations and support, and maintenance of the system. Ongoing operation and support is the process of ensuring that the technical system components continue to operate correctly and that the users uses them effectively. It works best when a person or a group has direct responsibility for keeping the information system operating. This responsibility is often split with the technical staff from the IT service department taking care of computer operations and members from the users department in the organization ensuring that users understand the system and use it effectively. As far as maintenance is concerned, the maintenance is the process of modifying the information system over time. As users gain experience with the system, they discover its shortcomings and usually suggest improvements. The shortcoming may involve problems unrelated to the information system or may involve ways that the information system might do more to support the work system, regardless of the original intentions. Maintenance is not separate phase, but a repetition of other SDLC phases required to study and implement the needed changes. Maintenance is of three types: corrective maintenance, adaptive maintenance, and perfective maintenance. If we talk about corrective maintenance, in this type, the errors that creeps into the system are removed. Hence, it has the name corrective maintenance. As far as adaptive maintenance is concerned, it is done to adapt with the changing external factors. And perfective maintenance is done to satisfy the user's requirement to make the system more and more perfect. The steps in each of the phases of the SDLC have now been introduced. The SDLC is a highly linked set of phases where output of one phase serves as input to the subsequent phase. Throughout the system development lifecycle, the systems development project needs to be carefully planned and managed. Therefore, the larger the project, greater is the need for project master. Now, we move on to Unit 11, that is Computer Programming and Languages. We'll start with overview and features of Visual Basic, what we in short call as VB. Visual Basic, originally called Visual Basic .NET, was launched by Microsoft in 2002 as the successor to its original basic Visual Basic language. The last version of which was Visual Basic 6. The .NET portion of the name was dropped in 2005. .NET is a framework that provides a programming guidelines that can be used to develop a wide range of general purpose applications, from web to mobile to Windows based application. The applications developed using VB.NET can also be run in other systems having Linux, Mac operating systems. Visual Basic .NET is an object-oriented computer programming language implemented on the .NET framework. Although it is an evolution of classic Visual Basic language, it is not backwards compatible with VB6, and any code written in old version does not compile under VB.NET. It is easy to learn and has strong programming features. Object-oriented programming, that is OOP, is a programming paradigm used on the concept of objects which can contain data and code. Data in the form of fields, often known as attributes or properties, and code in the form of procedures, which is often known as methods. VB.NET is widely used as a professional language for the following reasons. It is one of the popular modern language used worldwide for general purpose applications. It is based on object-oriented concept of modern programming techniques. It is easy to learn because its foundation is based on basic, that is what we know, beginners all-purpose symbolic instruction code, programming language, and VB6. It is a structured language The structured data type is used and defined and can be used to represent information about something more complicated than a single number, character, or Boolean data types can do. It produces efficient programming programs, meaning thereby that the codes written by VB.NET use optimal processing time and computer memory space. It can be compiled on a variety of computer platforms like Windows, Linux, Mac, and mobiles. Overview and feature of Java. Java is another language. Java is a high level, general purpose, object oriented language originally developed by Sun Microsystem of USA way back in 1991. It was released in 1995 as a core component of Sun Microsystems Java platform. Sun Microsystem was acquired by Oracle in 2010. As of October 2021, Java 17 is the latest version. The most striking feature of the language is that it is platform neutral language. It is intended to let programmers write once, run anywhere. That is WORA. Write once, run anywhere. Meaning that compiled Java code can run on all platforms that support Java without the need for compilation. Java is the first programming language that is not tied to any particular hardware or operating system. Java has become a popular and useful programming language because of its excellent features. The important features of Java are simple and familiar, compiled and interpreted, platform independent, portable and architectural neutral, object oriented, secure and robust, distributed, multi-threaded and interactive, high performance, dynamic and extensible. Programs written in Java are simple and easy to understand. It has a basic of familiar and pre-existing languages like C and C++ and removes the drawbacks and complexities of C, C++. Usually, computer language is either compiled or interpreted. Java combines both these approaches, thus making Java a two-stage system. Java compilers translate source code into what is known as bytecode instruction. Bytecodes are not machine instructions and therefore Java Virtual Machine, that is JVM, then executes these bytecodes, which is executable on many operating systems and is portable. JVM works on the as the interpreter, generating machine codes that can be directly executed by the machine that is running Java program. The most significant feature of Java is that it provides platform independence, which leads to a facility of portability. Being platform independent means a program compiled on one machine can be executed on any machine in the world without any change. Java achieves platform independence by using the concept of the bytecode. This is where write once, run anywhere slogan for Java comes in. Java is a true object oriented language. Almost everything is Java is object. All program codes and data reside within the object and classes. One cannot develop an executable program in Java without making use of the class. This indicates that Java very strictly applies the principle of encapsulation, which is one of the prime features in object-oriented programming, that is OOP. Java is robust as it is capable of handling runtime errors, supports other features, and has a strong memory master system. It helps in eliminating errors as it checks and code during run, compile, and runtime. Java also provides the concept of exception handling, which identifies runtime error and eliminates them. Java is garbage collected language as JVM automatically delocates the memory blocks, and programmers do not have a worry about deleting the memory manually as in other languages. Java is designed as a distributed language for creating applications on networks. It has the ability to share both data and programs. Java applications can open and access remote objects on internet as easily as they do on a local system. The performance of Java is impressive for an interpreted language because of its intermediate bytecode. Java produces high performance with the use of JIT. JIT is just-in-time compiler, in which the compiler compiles the code on demand basis. That is, it compiles only that method which is being called. This saves time and makes it more efficient. Java architecture is also designed in such a way that it reduces overheads during runtime. Java is dynamic and extensible means that you can add classes and add new methods of classes, creating new classes through subclasses. Now, overview and features of hypertext markup language, that is HTML. For website development and to produce information through web, we prepare documents in a markup language known as hypertext markup language. In short, we call it as HTML. This was first created in 1989. HTML is used to create pages and make them functional. Hypertext means the document contains links that allow the reader to jump to other places in the document or to another document altogether. The markup language is a way that computers speak to each other and control how text is processed and presented. To do this, HTML has two things: tags and attributes. Which HTML, we can describe the structure of our documents, including related informations such as integration of multimedia and the use of hyperlinks. It also links Java applets to our website. HTML is actually a subset of an internationally known standard called Standard Generalized Markup Language, that is SGML. The advantage of HTML is that we can create its documents with simple ASC2 text editor, which is not always true for the document based on HTML. HTML define documents so that any browser running on any computer can read and display them. The basic HTML commands that are needed to create web pages fall into following categories. Structural command. These identify a file as an HTML document and provide information about the data in the HTML file. Paragraph formatting command. These specify for paragraph endpoints and heading levels. Character formatting command. These allow us to apply various styles on the characters in our document. List specification command. HTML supports several list formats during bulleted, numbered, and definition list. Hyperlinking command. These allow us to provide information about moving from one document to another. Asset interaction command. These allows us access to multimedia information. Through these commands, we can display graphical images, access sound, and provide digital movies for users. XML and XHTML. XML is E-extensible markup language. Is a markup language designed to store and transport data. It is not designed to display data. XML is not a replacement to HTML. It is a platform independent and language independent. The main benefit of XML is that you may use it to take data from a program like Microsoft SQL, convert it into XML, then share that XML with other programs and platforms. Many corporations use XML interface for databases, programming, office application, mobile phones, and more. XHTML, that is Extensible Hypertext Markup Language, is a markup language which is written in XML. It is a hybrid technology between HTML and XML that combines the functionalities of both to become powerful and efficient. HTML is used for the presentation of the data, while XML is used for carrying the data. It was developed by World Wide Web Consortium, that is W3C, which is an international organization that sets standards for World Wide Web, that is WWW. Now, we move on to the features of Excel. Microsoft Excel is a program especially designed to enter organized data as well as to analyze and present the data attractively. Excel is one of the most versatile and popular spreadsheet programs. It serves as an electronic pad for accountants. It can easily perform simple as well as complex mathematical operations. Spreadsheet is a simple worksheet consisting of rows and columns in which any data can be entered. For example, report cards of students are manual spreadsheets. An electronic spreadsheet, instead of using on being on papers, it is on computer screen. Spreadsheets are used for performing calculations, recalculations, result if any data stored in them is changed, creating financial reports, comparing reports, etc. A spreadsheet consists of rows and columns which combine to form a cell. A cell is a box where we can enter data. Column form the vertical lines of calls, while rows form the horizontal lines of the cells. A cell is an intersection of row and column. It describes the location or address of a cell. We have to write the names of the column and the rows whose intersections have created this cell. Labels are the headings which we enter in cell. Values are the number on which calculations are performed. Formulas and function are elements that perform the desired calculations on the values. Formula which are present within the spreadsheet itself are called functions. A spreadsheet can be designed in numbers of formats. Basically, designing is concerned with how a number should look on the screen. The various designing formats are comma, percent, currency, scientific. The data in a cell may be right aligned, left aligned, or centered as per the requirement. The spreadsheet allows us to use different fonts and styles on emphasis headings. Graph is yet another powerful feature of spreadsheet. The data stored in the spreadsheet can be converted into graphs so as to study the relationship various data. The spreadsheet program has the facility to draw various graphs, bar graph, pie chart, 2D and 3D graphs. A spreadsheet allows the user to protect their workbooks by using a password from unauthorized access to their information. Now, we move to Unit 12, that is Database Resource Master. Data as organizational resource. Before the computer came into existence, there were many limitations associated with the physical handling of documents and human processing. Computers came into existence to speed up the data processing, and computers help to manage data. Database Master System, that is DBMS. Database Master System is software that is used to manage the databases. Now the thing is that what is meant by database? Yeah, what is database? The database is a collection of interrelated data which is used to retrieve, insert, and delete the data efficiently. It is also used to organize the data in the form of a table, schema, views, and reports, etc., as per the requirement. For example, the college database organizes the data about the admin, staff, students, faculties, and etc. Using the database, you can easily retrieve, insert, and delete the information. Database Master System is a software which is used to manage the database. For example, MySQL, Oracle, etc. are a very popular commercial database which is used in different applications. DBMS provides an interface to perform various operations like database creation, storing data in it, updating data, creating a table in the database, and lot more. It provides protection and security to the database. In the case of multiple users, it can also maintain data consistency. DBMS allows users the following tasks. What it can do? Data definition. It is used for creation, modification, and removal of definition that defines the organization of data in the database. Data updation. It is used for the insertion, modification, and deletion of the actual data in the database. Data retrieval. It is used to retrieve the data from the database, which can be used by applications for various purposes. User administration. It is used for registering and monitoring users, maintain data integrity, enforcing data security, dealing with concurrency control, monitoring performance, and recovering information corrupted by unexpected failure. What are the characteristics of DBMS? It uses a digital repository established on a server to store and manage the information. It can provide a clear and logical view of the process that manipulates data. DBMS contains automatic backup and recovery procedures. It contains asset properties which maintain data in a healthy state in case of failure. It can reduce the complex relationships between data. It is used to support manipulation and processing of data. It is used to provide security of data. It can view the database from different viewpoints according to the requirement of the user. What are the advantages of DBMS? It controls database redundancy. It can control data redundancy because it stores all data in one single database file, and that recorded data is placed in the database. Data sharing. In DBMS, the authorized users of an organization can share the data among multiple users. Easily, easy maintenance. It can be easily maintainable due to the centralized nature of the database system. Reduce time. It reduces development time and maintenance need. Backup. It provides backup and recovery subsystems which create automatic breakup of data from hardware and software failures and restore the data if required. Multiple user interface. It provides different type of users interface like graphical user interface. Then comes what is data modeling. An organization needs to store data in process and have the desired information, and this is done through databases. Data models refer to different views of data and the underlying relationships Among them, data modeling is a process of creating a data model for an information system. It gives a visual presentation of either a whole information system or parts of it. It shows connections between data points. Data models are built around business needs. Rules and requirements are defined upfront through feedback from the business stakeholders so that they can be incorporated into the design of a new system or adapted in existing one. The process begins by collecting information about business requirements from stakeholders and end users. A data model can be compared to a roadmap, an architect's blueprint, or any formal diagram that facilitates a deeper understanding of what is being designed. Data modeling techniques and methodologies are used to model data in a standard, consistent, predictable manner in order to manage it as a resource. What are the benefits? It reduces errors in software and database development, increases consistency in documentation and system design across the enterprise, improves application and database performance, ease data mapping throughout the organization, improve communication between developers and business intelligence teams, ease and speed the process of database design at the conceptual, logical, and physical levels. Data models are generally be divided into three categories. The process starts with a conceptual model, process to a logical model, and concludes with a physical model. The three data models are conceptual data models, logical data models, and physical data model. We start with conceptual data models. They provide view of what the system will contain, how it will be organized, and which business rules are involved. Conceptual models are usually created as part of the process of gathering initial project requirements. Logical data models, they provide greater detail about the concepts and relationship in the domain under consideration. They indicate data attributes such as data types and their corresponding lengths and show the relationships among en- entities. The third one is physical data model. They provide a schema for how the data will physically store within a database. As such, they are the least abstracts of all. They offer a finalized design that can be implemented as a relational database, including associative tables that illustrates the relationship among entities as well as the primary keys and foreign keys that will be used to maintain those relationships. Physical data models can include database master system, specific properties including performance tuning. All the above data models can be broadly classified into three: record based data model, object oriented data models, and dimensional data models. The record-based data modeling has been in practice since beginning of application software development using data-based approach. The three submodels are hierarchical, network, and relational models. Hierarchical models capture the intuitive hierarchy of the data element. The early generation of large DBMS, that is IMS Information Master System, by IBM belongs to the hierarchical data model and were widely used, especially in banking. Network models, since hierarchical models are unable to represent data items that existing at two different levels of hierarchy, network models were proposed. The notable systems built Using the models were ADABAS, IDMS, that is Integrated Database Master System, and DBMS-10. They were found to be more powerful and were used in various sectors like telecom, production, houses, etc. Relational models, though network models were quite powerful, they lacked the elegance and were not simple to use. DBMS with relational models is known as RDBMS. The system built on this model were DBase, Xbase, and Oracle. The latest as of now in 2021, Oracle 19c, SQL Server, MySQL are built in the relational models. Data modeling is RDBMS is achieved in two levels. ER modeling that builds the entities and provide entity relationship diagrams. The second one is normalization, which removes the redundancy. Object-oriented data models came into practice because of object-oriented programming, and it became popular in mid-90s. Objects are grouped in class hierarchies and have associated features. Object oriented databases can incorporate tables but can also support more complex relationships. This approach is mostly used in multimedia and hypertext databases. Object oriented data, that is OOD, modeling has advantage of getting more redundancies removed and hence uses less storage space as compared to ER model. Dimensional data models are designed to optimize data retrieval speeds for analytical purpose in a data warehouse. This modeling is typically used across OLAP system. OLAP for online analytical processing is software for performing multi-dimensional analysis at high speed on large volumes of data from a data warehouse, data mart, or some other unified centralized data store. Developments in database technology. DBMS consists of a collection of interrelated data that is called database and a collection of programs to manage and access the data. The RDBMS is collection of tables, each of which is assigned a unique name. Each table consists of a set of fields and stores a large set of records. The data warehouse is a repository of data collected from multiple sources, stored under a uniform schema that resides in a single site. There have been a lot of developments in the field of database technology. These developments include handling of spatial data such as maps, engineering design data such as designs of building, components and circuits, multimedia data such as text, image, video, and audio data, time related data such as historical record or stock exchange data and worldwide web data. Advanced databases, object oriented databases. There are basically three types. In object oriented databases, each entity is considered as an object. These objects can be customers, suppliers, employees, or items. Sub-object relational databases. In object relation data models, much is same as that of basic relational model, but for the fact that object relational model databases also handles complex data types and complex object structures. Spatial databases, these databases contain geographic databases, clip design database, medical and satellite images database, These data are represented in roster format consisting of n-dimensional bit maps or pixel maps as well as vector format. Time series and temporal database. These database contains time-related data. A temporal database usually stores relational data that includes time-related attributes. Text and multimedia databases. Text databases contain word descriptions of objects. These databases are used in applications such as picture content-based retrieval, voice mail systems, video on demand systems, and World Wide Web, etc. World Wide Web databases has data objects linked together to facilitate interactive access. User seeking information of interest transfers from one object via links to another. These databases are also called as virtual databases. Database and data warehousing. Database is a collection of data on a subject. The word data warehouse was first introduced by Bill Inman in 1990. According to him, a warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of master's decision-making process. A data warehouse is a central repository for significant pieces of data that are collected by various business systems. Data from various online transaction processing applications and other sources is organized on the data warehouse for use decision making process. A data warehouse is used in applications like data mining, web mining, and a decision support system, that is DSS. Data warehouse enables the executive manager or the analyst to make better and faster decisions. According to Iman, a data warehouse should firstly have a common format, meaning that data that goes into a warehouse should have a common data format. Since a data warehouse is made out of a combination of various organizational databases of the company, every care should be taken to maintain uniformity. Secondly, since different companies function such as sales, marketing, HR, finance, and production have some variables common in a database, a data warehouse will introduce these data pertaining to different topics. Thirdly, since data often contains time as a dimension and is updated into a database periodically, a data warehouse should be efficient in collecting all time and finally, since data warehouse are never deleted or updated, they should be able to sustain years of data, maybe economics or beyond. A data warehouse grows over time as new data keeps on adding. In practice, a data warehouse is always synchronized to keep its volume managed. The key to synchronization is the data is periods and analysis and when the most was the now we move on to unit 13, that is data warehousing and timing. Operational and operational databases. There are several reasons that compare information system designs to accept that even the latest cannot optimize to support both operational and informational processing in management. Data requires different information required is different, technology required is different, the user domain is different, access pattern is different, and processing pattern are different. These objectives provide the framework for competitiveness and growth in an enterprise digital model. To set realistic and achievable objectives and monitor the company's performance against them, managers need information on subjects like values, their needs and preferences, products the company offering to service competitors, as their cultural events, and distributors' location. It is also beneficial for KPIs like quantities of products and sales mix across phases like economically impact, and compare them with yardsticks like budgets, forecasts, previous year actuals, and industry averages. IT and its application, it is more effective as they will be considered as basic requirement for an online business. Information systems have evolved from the identified processing of 1960 to DMS, random access processing of 1970 to high performance targeted processing during 80s to season support system around the existing operational, informational, and virtual databases to evaluate the nature and the working state. A traditional IT department with limited resources and faced the need to provide strategic information using data in operational databases and themselves inadequately equipped to respond. The solution, it is an environment that is specifically designed to hold data required to support complex analysis and detection of patterns, trends, and behaviors. The characteristics of such an environment can be summarized as the view of the enterprise. Makes the enterprise current and historic information easily available, without hindering operations and renders the organization information consistent. Now, the data warehouse. The concept of data warehouse was given by Demon, the father of data warehouse. Data warehousing is a circulated, integrated, aggregated, non-volatile collection of data what we call as aggregation of data warehouse. Characteristics of a data warehouse. Subject oriented. Data warehouses data of an organization arrange and optimize to provide answers to questions coming from diverse functionality of the data. Therefore, the data warehouse contains data organized and summarized by metadata and keywords. That's my point. Such as sales, marketing, finance, distribution, transportation, etc. Time variance. ESS data includes in contrast to the operational data. Houses data represents the flow data. But data houses can be protected. Data as even not volatility. Because the represent operational data representing need the near directory implies a well-organized effort